All right, so Darren needs to bend this wire. So he puts a circular disc on and starts rolling it so it bends. So if the radius of this circular disc is 22 centimeters and the wire is 100 centimeters long here, how long is it from here to here? How can we figure this out? Let's brainstorm a little bit. How do I know the length from here to here? Is there any way to find the length all the way around a circle? What's that called? It's up there on a big chart. What's the distance around all the way around the circle called? Circumference, right? So if I measured all the way around the circle, it'd be the circumference. But I only measured 90 degrees of the circle, which is how much of the circle? How much of the circle is 90 degrees? 1/4 of the circle. 1/4 of the circle. So if I would take 1/4 of the circumference, then I would be able to figure out how far this is. Now, to figure out the circumference says 2 pi r. So, this chapter, you're going to use your calculators every single day on every single lesson because you're going to do a lot of typing on them. So, take 2 times 22 times pi on your calculator, and pi is the pi button. 2 times 22 times, and then push the pi button, which is, where is your pi button? Below the second button. Yep. The third one down from the second button. Okay? So if you do that, well, you're gonna get a decimal. 100 and what, 40-ish? 130 point what? 138? Whatever. 138. So it's 138 around the whole circle. But how much of the circle do we want? 1/4 of it. So divide it by 4. Take that 138, divide by 4. What do we get? 34.5. So how long is the wire? 134.5, because it's 100 here plus 34.5 there, 134.5. What we just did is figured out arc length, and we'll come back to arc length after a little bit. But arc measure and arc length aren't the same thing. The measure of an arc is how many degrees an arc is. Not how long it is in centimeters, but how many degrees it is. Okay? Now, when you name an arc, you use 2 letters if it's smaller than 90 degrees. You use 3 letters if it's bigger than 90 degrees. So we have, So here we have arcs KL, JK, MJ, LM. Those are all arcs that you see right there. But we also have arc JML. JML is a major arc, is what they call it, because it goes more than 90 degrees. You could have KLM. You could have KLJ. So when you go more than 90 degrees, you use 3 letters. All right. So, how many degrees are there in a circle? How many degrees are there in a circle? 360. So, the arcs have 360 as well. So, arc AB is 95. And arc is the same as its central angle. Okay? So what's left for arc ACB? What's left for this arc that goes from A all the way around to B? Well, if there's 360 in a circle and we use 95 there, what's left for the rest? 265. Because there's 360 degrees in a circle. So that's arc measure, not arc length. They're totally different concepts. Okay? What's the measure of arc XZ? Easy peasy lemon squeezy. What is it? 115. So then what is XYZ? 245. Okay? Arc length, the measure of an arc is what part of it is out of 360. Arc length is a fraction of the circumference. Arc length is a fraction of the circumference. So those of you with vocab sheets in front of you, that's the first word on your vocab sheet. So the measure of an arc is in degrees. Arc length is in centimeters or whatever they're measuring in. Okay? It's a distance. This is a distance in degrees. This is basically an angle measure. Now, the arc length over the circumference equals the arc measure over 360. Okay? Because the length of the arc is a number, as in a certain amount of centimeters over the whole distance around, equals the measure of the arc over 360. So what we do is to figure out the arc length, we just multiply both sides by 2 pi r. So arc length is the part of the circle over 360 times 2 pi r. And we'll get to that here in a second. Okay. The next thing is a radian. A radian is equal to the measure of the central angle that intercepts the arc with the length equal to the radius of the circle. So that's a little longer definition on your vocab sheet. All right. In trig class, a radian is a huge concept. It's a very important concept when we get to trig class. So, a radian is equal to the radius, the length of the radius. So if you want to figure out how many radians there are in the outside of a circle, there's one radian there. I didn't make this quite big enough. Let's go just a little bit bigger. There we go. There's another radian there. There's another radian there. There's another radian there. There's another radian there. There's another radian there with a little left over. There's 0.28 of a radian there. Okay? So how many radians do I have? I have 1, 2, 3, 4, 5, 6.28 radians make up a circle. On your calculator, take 2 times pi and see what you get. 6.28. Okay. There are 2 pi radians in a circle. Okay, because the circumference is 2 pi r. Okay. So 2 pi radians is the same as 360 degrees. So radians are just a different way to measure things on circles. Now, we're not going to work with that too much, but we are going to work with it a little bit. All right. So, what's the length of arc AD? Okay, from here around to here. What's the distance of the black line there? All right. So to figure it out, if you have things in degrees, that deals with geometry. Okay. So arc length is S. So S equals the number of degrees over 360 times 2 pi r. That's what arc length is. Well, if I have 73 degrees here, 43 degrees here, 104 degrees here, what's left for this angle? Because that's the angle I'm worried about. Well, 73 and 43 add up to 116 plus another 104 is 220. 360 minus 220 is 140. So that's the angle I'm worried about to figure out this arc right here. So it's 140 over 360 times 2 pi, and my radius is 4. My radius is 4. So, if I multiply that out, take 14 over 36 times 2 times pi times 4, what do we get? Oh, actually, don't multiply it by pi, because it says express your answer in terms of pi. So don't push the pi button. Take 14 divided by 36 times 2 times 4 and leave the pi. So how many pi is that arc length? $31.9 pi? Is that what you said? 3 1/9. Okay. So 3 1/9 is the same as 28/9, right? So that's probably the best way to express it is 28 pi over 9. 28 pi over 9. Okay. JK, from here to here. If it gives the answer in radians, okay, we're going to use the trig formula. The trig formula is super easy for arc length. S equals whatever your angle is times the radius. So it's 3 pi over 4 radians. That's the angle. Times your radius of 5 is 15 pi over 4. So when it's in radians, it's actually a little easier to multiply out. What's the arc length of HK? Well, that one takes a little more math to do. Because how many radians are in a whole circle? 2 pi radians are in a whole circle. Then we have to subtract 1/3 of pi and 3/4 of pi. Well, how do we do that? You take and get a common denominator. What's common denominator between 3, 4, and 1? Common denominator. 12. So if I want to make 12 out of this, I multiply top and bottom by 12. So it's 24 pi over 12 minus, to get 12 down here, it would be 4 pi over 12. And to get 12 here, I'd multiply top and bottom by 3, so it's 9 pi over 12. 24 minus 4 is 20, minus 9 is 11 pi over 12. That's the angle here. If we take that times the radius of 5, we get 55 pi over 12. So when you're finding arc length using trig, it's the angle times the radius. When you're finding the arc length using degrees, it's x over 360 times 2 pi r. Two different formulas. They are both on the board right here. Geometry, x over 360 times 2 pi r. Trig is your angle, and we use a little different way to say an angle in trig class, times r. All right. So if there's not pi's associated with it, then it's degrees. Okay? The radius of r is 7. YRZ is 94. YRZ is 94. So that means this is 94 out here. ZRW is 63. So then it's 63 out here. What is the length of WZY? We'll find the length of that, the arc length of that. We add up these two angles. 63 and 94 add up to what? You went 99. Yeah, 94. So it's 157 out of 360 times 2 pi r. Don't press the pi button. So take 2 times 7 times 157. And that's it. Just take 2 times 7 times 157. What do you get? 2 times 7 times 157. 2,198 over 360 times pi. Now let's reduce that fraction. So put it in as a fraction on your calculator. Use the fraction button, the A, B over C button. 2198 over 360 using the A, B over C button. And then go second, turn it into an improper fraction, please. So what is this equal to reduced as an improper fraction? Something with a 9 in it, I bet, right? Does it have a 9 in it? 619 pi over. Somebody's phone's going off. Over 180. Okay, that's the arc length. Okay, now the sector of the circle. It'll stop sometime. The sector of the circle is the amount of area. Is the amount of area enclosed by a circle. Okay, it's that amount of area. So the sector of the circle, and this is on your vocab sheet, for those of you who haven't noticed yet. The sector of the circle is the region bounded by 2 radii in the intercepted arc. This is called the intercepted arc. So it's the area of the pie-shaped piece right here. So the sector of the circle is the region bounded by 2 radii in the intercepted arc. So, I have arc length on the board. I also have sector area on the board, the formulas. Okay? So I got a trig formula and a geometry formula for that too. So if the angle is given in degrees, we use degrees. If it's given in radians, we use radians. Well, this is given in degrees, so we say, well, 78 over 360, the fraction of the circle times the area of the circle. The area of the circle is pi r squared. Find the area of a circle is pi r squared, as it says on the sheets up there. So the sector area is just a fraction of that. The angle out of 360, the part of the circle that is covered, times pi r squared. Okay. So Take this, and so it's 7,800 pi over 360, which is 780 pi over 36. So take 780 over 36, reduce it, change it to an improper fraction, and what do we get? What? 21 and 2/3, which is the same as 65 pi over 3. Okay, 65 pi over 3. Because I don't think our Savas will let you put it in that way. But they will let you put it in as an improper fraction. So know how to turn a mixed number into an improper fraction on your calculators. Okay, let's find the area of this sector. So it's 165 degrees over 360 degrees times pi r squared. So 9 squared is 81. So you take 81 times 165 divided by 360 times pi. So I don't know what that is off the top of my head. But it's a big number over 360. Reduce that fraction. And what's your mixed number? Something over something. What do we get? Layla, what'd you get? Oh, yeah, it should be 3 squared. Mr. Bierschbach. I squared 3 in my mind before I wrote it down. So it's 9 times 165. All over 360. No wonder nobody was offering up the answer, because you were all confused about Mr. Bierschbach confusing you. So 9 times 165, whatever that big number is, put it AB over C over 360, let the calculator reduce the fraction, and then change it to an improper fraction. And what do we get? 33 over 8 with a pi on it. 33 pi over 8. Okay, one more time. Area of this sector. How do we set it up? What times what over what? What do we do here? Ethan, what do we do? That is a good question. That's why I asked you. 59 over 360 times pi 10 squared. Pi squared. So 5,900 over 360, or 590 over 36 pi. Reduce that fraction. What do we get? What do we get? Sector area. All right. Next concept. Ooh, this is a big section. Lots of stuff in it. It's a segment of the circle. Hey, that's the next vocab word. It's the part of the circle bounded by the arc and the segment that joins the endpoints of that arc. So it's a little bitty area. It's that little bitty green area. All right. I know how to find this whole area. We just did that for 3 straight problems. We just found the area of the blue part, right? But I don't want that now. I want just this little area right in here. So how in the heck am I going to find that little tiny skinny piece of area, knowing how to find the area of the blue? What shape do I have that's blue right now? Triangle. Do we know how to find the area of a triangle? Yeah, we do. Okay. And we learned a new formula for the area of a triangle because we don't have a base and a height, but we have side angle side here. Because whatever this radius is what this radius is, because the radius of a circle is always the radius. It doesn't change. So if this is 8 and this is 8 and this is 65, I can find the area of the big blue area, the sector area. I can find the area of a triangle, and then I can just subtract those two. Now the sector area, and we're going to use decimals now, the sector area is 60 degrees out of 360 degrees times pi r squared. Let's change that into a decimal, so you're going to hit the pi button. So 60 over 360, which is 1/6 or 0.16 repeating, times pi times 64. Do that. Give me a decimal answer. 33.5. The area of the triangle is 1/2 one side times the other side times the sine of the angle in between those two sides. Give me that as a decimal. 1/2 of 8 times the sine of 65. And it better be less than 33.5. Because if it's bigger, you did something wrong, because a triangle is inside that sector. And we're trying to find the green area. So what's 1/2 of 8 times sine 65? 28-ish, 29-ish? 29.0. Okay. So we take 33.5 minus 29.0 is 4.5 centimeters squared. The area is always squared. Okay. That's the area of the segment. Let's do that one more time. Okay. This time we'll go a little faster. You find the area of the sector. The area of the sector is 90 in this case, because it's a right angle, over 360 times pi times 10 squared. Now, 10 squared is 100. 1/4 of 100 is 25. 25 times pi. Ooh, what's 25 times pi?
78.5.
Sounds good to me. That's the sector area. That's this whole thing. Now we have to subtract off the area of that triangle. The area of the triangle is 1/2 of 10 times 10, because you take both sides, times the sine of 90. So that's like 50, right? If we take 78.5 minus 50, we get 28.5. That's the area of the green area. Okay? All right. Should we do another one, or are you good with that? I figured you'd say you're good. All right. Chen uses circular corkboards to make watermelon coasters to sell at a craft fair. He paints one side of each coaster with special paint. Each jar of paint covers 200 square inches. Will one jar of paint be enough to paint all the coasters? And he's making 18 of them. Let's find the area of one. Multiply by 18. So if the diameter is 8, What's your radius going to be? 4. So find the area of the sector. Sector area is the angle 72 divided by 360 times pi r squared. Again, put pi in there because 200 has nothing to do with pi. So we need a decimal answer. Say 72 divided by 360 times pi times 4 squared. And what do we get? Something point something something. 10.05. Take that times 18 because there's 18 coasters. 181 point something something something. Okay? Is that less than 200? Does he have enough paint? Sure does. Okay? Okay, now these coasters he's going to wrap with decorative tape around each coaster. So to get the length around each coaster, we know this side is 4. This side is 4, but we don't know how much this side is. How can we find that? That is the what? That is the arc length. That is the arc length. So to find the arc length is 72 over 360 times pi times 2 pi r. Calculators, let's figure out the decimal for this one too. Something point something. It's going to be small. It's going to be around 4-ish. Maybe 5-ish. Maybe 6-ish. But it's not going to be very big. What is it? 5.02. Now, this side's 5.02. The other two sides are 4. That makes 8. So 13.02. If you take that times 18 coasters, how much decorative? Well, actually, for each coaster, because that's what it says there, how much tape does he need for each coaster? He needs 13.02 inches for each coaster. Okay, lots of things going on today. Degrees, radians, sector area, arc length, segment, the area of a segment. So, a lot going on. So, let me put out your assignment here.